In this problem, we are going to calculate the elastic modulus of a test specimen. And this specimen happens to be a cylinder that has length of 9 centimeters with a diameter of 1.1 centimeters. The measurement is taken where we have a force of 7 kilonewtons with a measured extension of 51 microns. And we're assuming at this point that initially the force was 0 with 0 displacement or 0 extension. How do we go about solving this problem? Well, let's recall Hooke's law that relates the stress and the strain to each other in uniaxial loading through the elastic modulus E. We'll also think about what the stress is in this situation. So sigma is equal to force over area, and the strain for uniaxial loading can be given as the delta over the L. Already we're starting to see some relevant parameters. We're seeing that there is a length, 9 centimeters. We're seeing that there's a diameter, which we can use to calculate area. We're seeing that there's a force, which is given here in the numerator, and there's an extension or a displacement of 51 micrometers, 51 microns, that comes in as the delta. Now, we can rearrange things and write that E is equal to FL over A delta by doing the substitutions and by by doing the algebra and the substitutions essentially. So this is one way that we can get to this result. Another way is to remember a formula that delta is equal to flee, or delta is equal to plea. So that's FL over EA. And this equation is useful in many circumstances, not excluding this one. And so what we can do is rearrange things such that we multiply both sides by E and we divide both sides by delta. And so we once again have delta is equal to FL, E is equal to FL over delta A. Let's go ahead and do the substitution of the parameters that we have in mind, and this would be the numeric result. Now, to calculate it out, if we've got a computer with access to the internet, we can use Google. So we'll plug in that we have 7 kilonewtons times 9 centimeters divided by, make sure you have lots of parentheses here, pi times 1.1. It's remembering things. That's, it's kind of interesting that it does that. Oh, and I'm making a mistake. I got to make sure that I have the centimeters squared in there. So squared over 4. And then I'm going to multiply by the 51 micrometers. So you could type out micrometers or you could type in microns like this. And it should be able to keep track of everything. Have I balanced my parentheses? I think so. And so what do we get? We get something like 1.3 times 10 to the 11 pascals. This is a pretty big number. The question was asking us to write it in gigapascals. So once again, we can write in gigapascals, and it will come out to be about 130 gigapascals. In Python, we can create a script that we'll use in Colab by doing the following or doing the prior if you like. And we'll go ahead and type in our values of concern or parameters that were given. So the force was 7 kilonewtons. So we'll do 7. And if I do kilonewtons, I'm like, oh, no, I got to do times 1,000. And we'll keep that in terms of newtons. The length, no, not centimeters, right? But we'll multiply by 1/100th, and that will give us in units of meters. We can do it either way, but let's do the diameter, and we'll say it's 1.1 centimeters, but no. E to the -2 gives us meters. and we have a uh, delta, okay, which was given as 51 microns. So we could write it like that, but no. We'll do e to the minus 6 meters like that. And we can then say E is going to be equal to F times L. Okay. And this is where we can make some decisions, but I'm going to go ahead to keep things maybe a little bit simpler, and it already knows, calculate the area in another line. Okay, just like that. So now I've got A in the denominator, making sure that I add parentheses so that both the A and the delta end up being in the denominator instead of just A. And that's just part of order of operations. We will go ahead and print the elastic modulus like this. And if I keep it like that, that would give it in pascals. But if I want in gigapascals, I'll go ahead and multiply this by 1 e to the minus 9, 3 minus 9, and I'll see what I get. And once again, we get 130 gigapascals. So I hope you find this example helpful and this information useful. Thank you.